So we've been talking about arc length, and we're going to do a little bit more arc length today, but we're going to do something a little different than what you're used to. You're used to angles being measured in degrees, but they can also be measured in a unit that's based on arc length. So when we see a circle and we see an angle like this, we think of this as something like 45 degrees is how much this angle opened. But that's just because we're thinking about it as degrees. If we thought about it as circumference, well, that angle also opens this far, however long this is. Now, we don't know how long it is, but if we knew the circumference, we could figure it out. So this type of measurement that we're going to use is called radians. And we are just going to touch on it here in geometry, and you will spend a lot more time with it in pre-calculus in a couple of years. So the radian measure the radian measure uses this symbol, and it's called theta, and we say it like this, theta. It's a Greek symbol. It's used to represent the radian measure of an angle. So the radian measure theta of a central angle is the ratio of the arc length to the radius. So if we look at this picture over here, it's the ratio of the arc length to the radius. So to us, a ratio is a fraction, so it's the ratio of the arc length to the radius. Okay, all that says is a radian is the arc length divided by the radius. So real quickly, come down here, see a quick example. We have given an angle in radian measure. So right here, that's telling us how far this angle is opening, not in degrees, but in radians. So theta equals 3 pi over 7. But we also know that from our new formula, theta equals the arc length divided by the radius. So if we substitute what we know, that 3 pi over 7 is theta, and that equals our arc length, which is what we're trying to find, divided by our radius, which is 5, we quickly have an easy little algebra problem to solve. We'll multiply both sides by 5, and we're going to get that the arc length, L, is 15 pi over 7 centimeters. Now, 15 times pi, you can do that on your calculator, divided by 7, and you'll get an actual number of centimeters. But for what we're doing, this is what we want to leave our answer as, so in terms of pi. So we'll try again over here. So we get our angle in the middle is 3 pi over 4 radians. But we also know that theta equals arc length divided by the radius. So we're going to substitute for theta, 3 pi over 4, and that's going to equal our arc length we need to find divided by 9. Now you can also cross multiply here, but you're just going to wind up dividing by 4 anyways. So just leave the 4 where it is, because it's already divided by 4. So our arc length here is going to be 27 pi over 4 centimeters. Okay, and what we found in both of these is just how long this is, not in degrees, which is what we did yesterday, have been doing, but in actual centimeters. So that sometimes can be a lot more useful information. Okay, one of the problems with this idea is usually we're given angles in degrees, right? So they give us degrees. Well, you can easily convert to radians just using this simple step. So you take your degrees and you multiply it by pi over 180. Now you'll spend a lot more time in pre-cal with this, getting into the who and the why and the how and all of it from this. From right now, we're just gonna touch on it. So just remember, to convert from degrees to radians, you multiply by pi over 180. So convert the following degree measures to radians. So 70 degrees, we're going to convert it, so we're multiply it by pi over 180. So that's 70 pi over 180. We're going to have to simplify some fractions, right? Zeros on the end will cross out. So now we're at 7 pi over 18. 7 and 18 won't reduce anymore. And remember, the pi, leaving terms of pi means the pi just comes along for the ride. We don't do anything with it. So 120, convert it to radians. Pi over 180. 120 pi over 180. And again, just leave the pi, just take it along for the ride. So 0 on the end, 12 over 18. You can divide both of those by 6, and we get 2 pi over 3. All right, last one, 315. Same as the last time, pi over 180. So we get 315 pi over 180. Now, if that one's a little big for you to try to reduce quickly, just do 315 over 180 in your calculator and do the math frac and turn it into a fraction. You can also take 45 out of both of these. That's the biggest number that goes into both of them. So this would turn into 7 pi, and 180 is 45 times 4, so it's 7 pi over 4. But that's it. Quick and easy. That's how you convert from degrees to radians. Take your time with this and have a great day.